In this tutorial, we'll cover the basics of abstraction and how to use it to speed up your development. If you're new to the FilledStacks channel, please subscribe and I hope you enjoy this tutorial. This video is a part of a series of abstraction that will cover non-theoretical, practical examples of use cases for abstraction that will improve your development experience or your application's code. We'll go over the definition of abstraction, and then after we will cover a practical example as well as how it looks within Flutter code. So what is abstraction? Abstraction is the act of dealing with the ideas or higher level functionality without knowing what the implementation will be. Within programming, this is done by providing an interface that describes functionality. The code you write will then make use of the interface and not of the implementation of that interface directly. So why do we need abstraction? Abstraction is required when you want to decouple your implementation details from your application. And why would you want to decouple your application code from your implementation details? Well, there's a few reasons for that. The first one is long-term maintenance. Since your business logic is written against your interfaces, not the implementation, for as long as the interfaces returns the expected values, you can change your implementation multiple times without having to worry about system-wide refactors. It's easier to understand. Using abstraction is considered a declarative approach to programming. This means we take a high-level approach to telling the compiler what to do and leave the implementation details out. When you're reading declarative code, you're reading what the code is doing, not how it's being done. This makes it easy to consume for any level of developer. It allows you to focus on the business logic and only go to the implementation details if you require to. It's easier to test. One way to make sure your implementation change didn't bring any bugs is by running your unit tests that confirm what's supposed to happen given a request on any interface. If you have a level of abstraction that allows you to supply mock versions or fake data versions, you can write more robust unit tests that cover a wider range of functionality. You can swap out implementations at any time. The biggest example of this they usually use is by saying that if you develop your database and code against that interface, you can swap out the underlying database with whatever you want and the rest of the code won't know that it has been changed. This is a very valid example, but I've never seen it happen in the real world since your tech lead usually decides on the database given a lot of research beforehand. And if it does happen, it probably happens 1 or 2 years down the line when something actually better does show up than the technology that you've chosen. The example that I like to use is for practical development improvements. These are things that can speed up your bug fixing, your testing, and the overall development process. This will help you get a product to demo faster, and you can have a more robust demo build to give to your clients that will inspire more confidence in your skills. I'm talking about swapping out a dependent service like an API with an implementation that returns exactly what you require for a specific scenario in your app. When you have this level of abstraction, you can maintain two versions of your implementation that you can supply to your app at any time. You can have your actual implementation, and you can have a fake version that returns the perfect data for you to have a perfect demo or test any functionality. The rest of the video we'll cover this later because I have to show some code, so let's finish with the benefits of abstraction first. One big benefit of abstraction is also that it speeds up the architecting of your application and makes it easier to develop your architecture. What I mean by saying this is that you and your team can sit down in a room, define your architecture, define all the services with its interfaces, define the functionality on those interfaces, you can define how they will interact and which services will be using each other, what methods and properties they have, and how you'll make use of it. And then once that's done, you can hand out an interface to each developer and they can start putting in the implementation details. You can develop your entire architecture using fake versions of these implementations so that you don't waste time on the implementation details until you've sorted out the actual architecture. The last benefit and the code for this video will be around fake data. Fake data is king, and abstraction will allow you to use fake data within your app efficiently to allow you to faster develop your application. The previous 3 points are all a version of fake data, but it still requires its own point because I want to make some other things clearer. You can set up and supply fake data implementations of all your services, the ones that depend on outside forces. You can take a few hours for the initial setup to set up services to return some fake data, and then you can start developing. I've actually used this many times, especially when a new feature has to be developed on the backend, but you want to start showing the functionality to a client before that's even complete. I've also used this to build robust demos, and when it's time to implement, you don't throw away any real code. You can even start developing the app before the API is complete, and this can help you define the responses the app requires to function. So having your abstraction and supplying the fake data is a very big benefit, especially during your development and when you have certain bugs that you need specific sets of data to be returned for it to show up. Okay, that's enough of the theoretical abstraction talk. I want to give a practical example of what I found very useful during my development of mobile apps. Using abstraction and supplying fake data, or more importantly the exact data, means that you won't be stopped by network issues, by offline problems, by server outages, or anything of that nature. This means that your client-side development can start immediately, before your backend service API is complete, before the tech lead has decided which database to use, and before any real implementation details are decided, you can start building your app and writing the code that will actually be used for it. Let's use the API as an example and set up the abstraction with some fake implementations as well as a real one. You can open up any Flutter project, and we'll start by creating an abstraction for an API, and then we'll supply two different implementations depending on a Boolean flag. Create a new folder called services under the lib folder. Then inside that folder, create a new folder called API. Then create a new file called API where we will define our interface. We'll define an abstract class called API. This will be custom for your application, but we'll define 4 functions to get the point across. We'll define a function that returns a future of type login response. It'll take in a username and a password. Then we'll define another function that returns a type future of type user called getUser, and it will take in an integer for the user ID. Then we'll define a function that returns a future of type list that returns posts, and it will be called getPosts for user, and it takes in a user ID as well. And the last function will be a function that returns a future with a list of comments, and it will be called getComments for post, and it will take in a post ID. Then we'll go ahead and create the models that the API returns. So under the lib folder, create a new folder called data models, and in that folder create a file called API models. The first class we'll define is a post, and we'll leave that empty. The second class will be the comment, and that will be an empty class as well. The third class will be a user, and we'll give it a name. We'll also give it another string for the phone number, and we'll pass that in through the constructor, and we'll make it named parameters. The last class we'll define is the login response. This will have a property called success that is a Boolean. It will have an integer for the user ID, and we'll also have a string that contains a message. We'll pass these values in through the constructor, and we'll make it all named parameters. Now you can go back to the API interface and import the API models file. This is our typical interface will look in Dart. You define only the functions and no bodies, and whichever class has to use this interface will implement this and supply the override functions that define the bodies. Within the API folder, you can now create a new file called fake API and another file called HTTP API. In the fake API file, create a class called fake API, and we will implement the API interface that we just created. You can use the quick options to create the 4 missing overrides. Then you can copy all the code in the fake API class and paste it in the HTTP API class, and then you can rename from fake API to HTTP API. We will cover the setup of your abstraction-based programming using provider as well as the getit package. We'll use a constant boolean at the top of the file to switch between implementations. This way we can turn them on and off during development. Head over to the pubspec file and we'll add the getit package without any version as well as the provider package without any version. We'll do the getit setup first and then the provider after. Go to the lib folder and create a new file called locator. We'll import getit and then create a new instance called locator. Then we'll create an empty function called setupLocator. Go over to the main file, and before we call run app, we'll call setupLocator from the locator file. Then we'll create a constant boolean at the top of the class called useFakeImplementation. We'll give it all uppercase letters, and the spaces in between will be underscores. And we'll give it a default value of true. Then in the setupLocator function, we will call register lazy singleton, and this time we'll give it a type of API. And in the factory function that returns the singleton, we will check if we are using the fake implementation. If that's true, we'll return the fake API. Otherwise, we'll return the HTTP API. Now you'll be able to come into this file and switch your fake data on and off based on your current environment, if there's any network outages, and so on. When you request the API in your code, you don't request the implementation. Instead, you request the abstract API class. That is all you need to develop against an abstraction instead of the implementation. Let's go over the same thing for the provider setup. In the lib folder, create a new file called provider setup. Inside the provider setup file, we will have a list of providers that return the type of single child clonable widget. You can copy this list 3 times. The second list will be called independent services. The third list will be called dependent services. And the last list will be called UI consumable providers. We'll use a spread operator to add all 3 lists into the providers list at the top. Make sure you update the SDK constraints so that your Dart version can handle the spread operator. We'll start by setting up the same boolean at the top of the file called useFakeImplementation. Then in the independent services, we'll register a new provider of type API. We'll use the value constructor, and for the value, we'll check if we are using the fake implementation. If we are, we'll return the fake API. If not, we'll return the HTTP API. Now back in the code where we request our API, we can get the same API by using provider of call, and we'll supply the type to the of function, and we'll give it a type of API. So how do you go about faking your implementation, and why would you want to fake it in the first place? There's nothing special about supplying fake data. You basically just hard code whatever you needed to return, and that's all you do. The process that I have found that works the best is by starting off with a single use case that is the perfect use case for your API. And instead of changing the fake data that you already created, you'll always add more use cases until you have covered every single use case in your application. We'll start by logging in with a username Dane, and you'll get a full profile, you get multiple posts, you get comments that has likes, etc. It's the perfect flow for a demo, so you know exactly which user to log in with if you want to demo your application. Then as you develop your application and you finished developing your core functionality, you can start moving on to profiles that has less information. You'll add a new case instead of modifying the old one. You'll leave out some user details. You'll return less posts. Some don't have comments and some don't have likes. There's no images, etc. Then you can end up fleshing out your entire application to cover every scenario without relying on the actual API. You'll eventually end up with a user profile that throws an exception on every single call. This will allow you to create a robust application so that if anything goes wrong in the real world, your app will be able to handle it. If your API returns the data that you expect it to, your functionality will not have to change one bit when you swap out the fake API with the real API. The first thing I usually do with a fake API is to delay every call by 1 second. You can add this as an optional value so that you can change your delay time so that you can also work on your timeout functionality. We'll start with a login function that will check for the username equals Dane, and will return a login response with user ID 1. Then for the getUser function, we will check if the user ID equals 1, and we will return a user object with all the data filled in. Then we'll do the same for the posts. We'll check if the user ID is 1, and we'll generate 10 posts and return that to the caller of the API function. You get the point of going through every function and adding your use cases. You develop your fake API through your development process, so there's no need to sit at the beginning and figure out what data to return. You'll only add data and more functions to your fake API as you require specific scenarios in your application. If you want to test your null functionality, you start adding your cases to return nulls. If you want to test your timeout functionality, you start adding your cases. to delay the call for longer, and so on. If you want to test your exceptions, you add the case that will throw an exception whenever you log in with that user. And this will allow you to create a robust application, and it's all through the benefit of abstractions. Next week, we'll be covering the benefits of abstraction through unit testing. So I'll show you the unit testing process that I follow and how abstraction benefits that. Thank you for watching. Please like and subscribe, and I'll see you guys next week.